Hi, this is MarqueeCrew, and today I'm joined with my friend Tessa Enns, and we're going to introduce you to some options around spatial tools in calculating distances.
Yeah, so I have two input data sets. One is target location, all the target stores near me. And the second one are the two locations of my offices that I visit at work. So I want to know what are the two closest targets to me, depending on what office I'm in for the day. So first thing, I included my spatial points with the create points under the spatial category. Then I appended the fields together so I could get an inclusive data set with every possible starting point and ending point. Then I generated additional rows, and then I put in the distance tool so I could figure out in miles how far away each target is from each of my offices and output that on a map.
Okay, so I'm going to go and just explain to people about the generate rows. When we're testing with 2 times 5 equals 10 records, Alteryx is just going to blaze through it that fast. We won't be able to see it if you blink. So we're going to use a generate rows, and for every record that it sees, it's going to copy that record 10,000 times so that we've actually got a good number of records to come through this distance calculation. When I hit play, we see it pause, it's thinking, it's working, it's taking 10 records on input, 100,000 records on output, and it's giving us those um, calculated distances now uh, in the Browse Everywhere tool, but you can see different numbers in the Browse tool. And it's now trying to generate the map against that. And all of that 100,000 records were calculated in 7.6 seconds, blazing fast. Still. Now, an alternative to that is using this Hammersteins formula. And the Hammersteins formula itself is a bunch of trig. And if you're good with your math and your trigonometry, this is going to be really simple for you. But to translate that into Alteryx, I looked in the community esri.com and I found a Python script that was very easy for me to take and convert each of these variables into something that could be consumed quickly in Alteryx. So let's remind ourselves where we were with time, 7.6 seconds, and hit play. I'll assure you that when I tested with 1,000,000 records, it took 11 minutes and 20 seconds to process. And with the formula, it took 2 minutes and 20 seconds. So there is some scale that's going to happen when you get into larger volumes. But when I go to implement that with the Hammersteins formula, it's still a little bit of work to ask users to implement the formula. So what I did was I created a find closest macro, and we're going to publish that on the Alteryx gallery. And so using the find closest macro, I'm now going to try to run this again. It's through, and this time we're going to get 100,000 processed in just under 1 second.
Wow. Let's see.
So the crew macro outperforms the standard Alteryx tools hands down. Now, there's probably a little bit of smoke and mirrors or something you might think about this, but I did show this to several aces, and we all agree this is a potential time saver for people working with large sets of calculations. So the find closest allowed me to configure and say that for my target and source locations, these are the fields that are the latitude and the longitude. And then even though the name says find closest, it is possible to just use it for the heavy lifting of calculating distances. And so what we're doing here is we're not finding the closest, we're just calculating all of the distances. And so that ran in just under a second to go and calculate all these distances. But let's see what the impact is of those points, calculating the create points play. So now we've put lead weights on to this macro and calculated points. And we can see it's taking more than that 1 second to run. So if you don't need the points, don't put the points on. I think that that's a good lesson to learn. It runs in almost 14 seconds. So it runs that much slower if you're creating the points. So if you're not going to use them, that's one of the key advantages of this macro, is that you don't need the points. You're also able to do things like the find nearest tool to say, within 25 miles, I'd like to find up to the 3 closest records to run, and be able to run that. And in this case, I've got 60,000 records on output, and it runs in 1 second. That's the find closest macro. Any questions?
Well, you know, Mark, I love this macro. I love the time piece, the time saver element. My only question is about the accuracy element. So help me understand, what is a more accurate reflection of distance, whether it's the spatial create points or if it's the formula that you showed? Or is it unknown?
Well, I think it's known to the African swallow. That's a Monty Python reference for those of you not familiar. The crow flies is the measure of the distance around the sphere of the Earth. And so it depends on which mathematic formula is being used for the accuracy. When we're looking at distances within 25 miles, maybe you're going to be off between any two calculations by a matter of feet. Is the truth. Did we ask the crow, or did we ask Alteryx, or did we ask Google? So I think that for general purposes and for the benefit of speed, they're both equal.
Sounds fair to me.
Okay, so if you would like to play with the find closest macro, we're going to post that onto the gallery.alteryx.com, and you'll be able to search for it with crew find closest. And please give me your feedback, your subscriptions to my YouTube channel. Let me just bring Tessa's visual aid into play, and I hope to see you again on a future YouTube video. Bye.